Luigi Dallapiccola's Quaderno Musicale di Annalibera is a collection of 11 short pieces for solo piano, composed as a musical gift for his daughter on her 8th birthday. Its 11 movements are unified by a single row class. The central movement and the focus of this talk is titled Fregi, the Italian word for friezes. A frieze is a decorative horizontal band, several examples of which are shown here. These patterns are generated through translation, reflection, or combinations of these operations. In music, similar relationships arise through transposition, inversion, retrograde, and retrograde inversion. These visual patterns provide a useful framework for understanding Fregi, a serial work built on pattern and transformation. Let's begin by listening to the movement. I'll highlight all 6 row forms employed by Dallapiccola while we are listening. This performance is by the Italian pianist Roberto Proceda. Before examining the movement's pitch organization and rhythmic motives, it is worth noting that the meter is also carefully organized. The time signatures follow this pattern. Like the pitch organization, the meter is built on repetition and symmetry. As we have seen, the movement employs 6 row forms, shown here in order of appearance. I will refer to them simply as rows 1 through 6. They form 3 strictly inversional row pairs at T9I, rows 1 and 4, rows 2 and 5, and rows 3 and 6. Since each pair shares the same TNI relationships, the opposing pitch classes are identical in every pair. These inversional pairs also share identical rhythmic profiles, forming paired musical objects that reflect the patterns of a visual frieze. Before we begin, a quick note about terminology. Rather than referring only to order positions, I'll use a more informal shorthand when comparing invariant pitch class segments. For example, I'll describe invariant tetrachords as occurring 1 note in from the beginning of one row and 1 note in from the end of another, as shown here with tetrachord segments. I'll use the same terminology for invariant hexachords. This terminology emphasizes the mirrored placement of these segments across row pairs, revealing reflected patterns analogous to the repeated patterns of a visual frieze. Here, rows 1, 3, 4, and 6 are shown individually. Attention is directed to the tetrachords that occur 1 note in from the beginning of the row and 1 note in from the end. Tetrachords 11, 3, 6, 8 and 6, 8, 11, 3 occur in rows 1 and 6, while tetrachords 3, 1, 10, 6 and 10, 6, 3, 1 occur in rows 3 and 4. These tetrachords exhibit several recurring relationships. The non-invariant tetrachords 1 note in from the beginning of rows 1 and 4 share identical rhythms. Likewise, the non-invariant tetrachords 1 note in from the end of rows 3 and 6 also share identical rhythms. In addition, all 4 tetrachords belong to the same set class, 0, 3, 5, 8. Next, we'll see that the transformations between the corresponding invariant tetrachords are also identical. In each pair of invariant tetrachords, the two constituent dyads exchange positions, while the internal order of each dyad remains unchanged. In other words, the dyad pairs simply swap places, revealing yet another recurring pattern. The next set of transformations contains invariant tetrachords at the beginning of rows 1 and 4, both belonging to set class 0158, as well as an invariant dyad one position from the end of each row. The tetrachords and dyads share identical rhythmic structures, reinforcing their relationships. In each case, the dyads reverse their order positions, creating another layer of frieze-like patterning. Like the tetrachords, 4 hexachords also occur one in from the beginnings and endings of the rows as shown here. The hexachords in rows 3 and 6 share the same rhythm as do those in rows 1 and 4. The hexachords in rows 3 and 4 and those in rows 1 and 6 are invariant, and all 4 hexachords belong to the same set class. The invariant hexachords also exhibit the same pitch class mapping. In each pair, the first pitch class becomes the third, the second becomes the first, the third becomes the fourth, and the remaining pitch classes follow the same positional pattern. Thus, the way the invariant hexachords map onto each other reveals yet another layer of structural organization, as shown here. In rows 2 and 5, Dallapiccola uses 4 discrete hexachords, each belonging to the same set class. In both rows, the opening hexachord is completed by borrowing the final pitch class of its preceding row. Row 2 borrows from row 1, and row 5 borrows from row 4, forming another layer of patterning. The non-invariant hexachords share the same rhythm, while the invariant hexachords, once again, exhibit identical pitch class mapping. The first pitch class becomes the second becomes the sixth, the third becomes the fourth, and the remaining pitch classes follow the same positional pattern, creating an additional frieze-like layer of organization. Finally, rows 1 and 6 begin and end with the same pitch classes, as do rows 3 and 4, contributing another layer of symmetrical frieze-like organization. Here is a recap of the invariant segments explored throughout the movement. These include invariant pitch classes at the beginnings and endings of paired rows, invariant tetrachords and dyad pairs with shared rhythmic patterns and transformations, discrete invariant hexachords, and invariant tetrachords and hexachords occurring one in from the beginning and ends of the rows. Seeing all these transformations together reveals the larger network of relationships across the 6 row forms. Now, if we remove the row labels and pitch class numbers, replace them with color, retain the background bands representing the 3 rhythmic patterns, and rotate the image 90 degrees, we arrive at the frieze that has accompanied this presentation all along, one derived directly from Fregi. Thank you for listening.